Hello guys, I want to, with the wave discussion, be helpful but not too helpful, kind but not too kind. So you see in front of you, I guess some of you are having trouble loading it, the simulation that we're using from Physics Classroom. And when you first open it up, it looks rather weird, this floating snake in the air of some sort. So the first thing I'm going to do is move the frequency up until we have something that looks like a wave. So there's the wave that we're used to, right? So we've got the crest, the trough. We could count the number of waves from crest to crest or trough to trough. We see the amplitude, how far it is above that darker line, right? All the words that we are learning. Okay, well, I'm going to walk through some things on this simulation. I am not going in order of the wave discussion questions. I am not going to tell you which questions I'm thinking about as I walk through it, and I might even throw in some extra information just like I did with crest, trough, wavelength, and amplitude, right? You can watch those little red dots going back and forth. All right, over here it says show wave. I can't expand this like you guys could if you wanted to with this button here because I want to go back and forth between two documents. Show wave. So here's another wave, right? So we'll talk about this, right? Look at those red particles moving back and forth. Look at these red particles moving back and forth. Okay, well, let me get started. The first thing that I'd like you to note is this particle is moving up and down, right? The particle's moving up and down. If I were over here on the beach, right, if I'm standing here where my cursor is, that wave's going to come in and could knock me over, right? Mess up my sand castle, wash up on my feet, right? However you want to think about that. That wave is coming, all that energy is coming to me, to my feet. The water isn't. The water is just going up and down in this case, right? Waves transfer energy. That energy is passing, right? With my cursor, that energy is passing. Particles' mass do not transfer. It is the same. It is the same. This is one of your questions in a longitudinal wave like this one. Notice the particle is just moving back and forth. I'm going to speed up the frequency. And you can see this compression, right? Compression and rarefaction. Compression where they're pressed together, rarefaction in between where they're a little bit rare, right? A little bit separated. It's really kind of cool to see. You can see the compression wave moving. You can see all that energy moving from one side, right, to the other. So the energy moves. All waves transfer energy. That particle is not moving from one side to another. Particles are just vibrating back and forth. So this is one of the answers to one of your questions. These are the same because all waves transfer energy. They do not transfer mass. They do not transfer particles. Well, how are they different, right? So this is a transverse wave. You see this particle moving up and down here, right? Well, go over here to my publisher document and let me just superimpose this. So that particle's moving up and down. It's right, left for the equilibrium, right? Well, oops. Let me grab all of this. I'm trying to be clever here. Well, you could relook at that and you could see a T for transverse, right? You could see a T for transverse. Or you could look at it, and we can use a math symbol. We've got the perpendicular or right angle symbol that you would use in math class. This is a transverse wave where the particles move at right angles perpendicular to equilibrium, that gray line back and forth, right? So that's a transverse wave. This is a longitudinal wave, right? Longitudinal wave, or because of these compression waves, also called a pressure wave. Let me go back over here. In this case, the particles are moving along, right? Along, we said in class. They're moving along the wave. These are longitudinal waves. So we've got the T, for transverse, and we're moving along for longitudinal, or the pressure wave that you see. Okay. How are the waves similar? They both transfer energy but not mass. How are they different? Transverse waves work perpendicular. The particle moves in a perpendicular way, 90 degrees. In a longitudinal or pressure wave, it moves in a parallel way. Good. That's 2 of your questions. You answer those 2 questions in number 5, and you've got this assignment down. All right, but let's keep going. I'm going to change the frequency. Well, wait a minute. Forgive me. I'm going to suggest, I think, for the rest of these that we go back to the transverse waves. Again, sound waves are represented as transverse waves because that is just too hard to see. How much pressure is there, right? Is it high frequency, low frequency, right? It's really hard to tell in those particles. So we talk about waves, we generally talk about transverse waves, but all sound waves are mechanical and longitudinal. Those particles are moving. Okay. I feel like I'm stumbling away through this, but hopefully this is helpful. All right, I'm going to change the frequency. So the frequency is pretty high. You can see how many waves I have. There's not really a pause button on here. Where is it? Okay, yeah, there's the pause button. All right, so I'll start here. 1, 2, 3. I have 4 waves. Okay, well, what's going to happen if I slow it down? Right, less frequency, less waves per second. Notice I now only have 1 wave. High frequency, small waves. A lot of waves coming at you real quick. Low frequency, big waves, right? Frequency and wavelength, as we've discussed, are inverse proportional. Inverse. In is a prefix which can mean not. They do the opposite thing. One goes up, the other one goes down. All right. Let's push this up a little bit. Let's change the amplitude. Again, there are 1, 2, 3-ish waves, right? 1, 2, I guess 3 and just a little bit away. So notice how many waves there are. There's 3 waves. I'm going to change the amplitude. I'm going to lower the amplitude. I'm going to lower the energy of the wave, right? Amplitude has to do with energy. This wave, again, if I'm standing here at the beach, is not going to knock me over. It's going to maybe get up to my toes, right? Maybe lap at the sandcastle that I've built. 1, 2, 3 waves. Changing amplitude did not change frequency. It stayed at 0.716 this entire time, and therefore it did not change wavelength. Amplitude and frequency have little to do with each other. Again, in class, we've played around. This would be somebody who's quietly whispering, not much amplitude, right? This would be somebody yelling, a lot of energy. The same person with the same voice, right? An older man with a low frequency, low pitch yelling, right? An older man whispering. A girl, right? She's whispering like this, right? And then now she's yelling that same pitch really loud, right? All right, sorry, I did it again. All right. All waves transfer energy. They do not transfer particles. Notice that particle going up and down. It's not going left to right. There's a difference between transverse, which moves perpendicular, and longitudinal, which moves parallel. I increase the frequency, I decrease wavelength. I decrease frequency, I increase wavelength. These are inverse. The amplitude has nothing to do with the frequency. These are absolutely different. Wave amplitude is about energy. All right, there's final question, question number 6. I've decided not to go over. It's not on the quiz, it's not on the IA3. So I would suggest you don't go there. But I've just answered 1 through 4. And in a way, I've given you one example from number 5 because I keep discussing water waves. I've sort of given you a second one in that I keep reminding you that this is what a sound wave looks like. That pressure wave is coming towards your eardrum. All right, y'all, I think this has been helpful as you answer the wave discussions. Please answer in complete sentences. I am not giving full credit. If the grammar and spelling is very poor, I simply can't. I'll take about 5 points off of every 20 points I give. Okay, thanks a lot, guys.